I'm going to try again. So earlier I was doing a video and then my children needed their mom. So I'm going to try again to finish this. So we were working on the unit test and here's the question. So let me record it, pop it over and go. And if you're wondering, if you can hear the background, my family is watching The Office as loud as could be in the other room. Um, so Um, log base 2 of 1 over 50 is approximately. Okay, so they're asking me to use a calculator. This is base 2. So if you're going to use the calculator that's in Khan Academy, it does not have a log base 2. You could do it, and I can show you that here in a second. But if you just want to use Desmos, you can. And you go over here into Functions, Miscellaneous, log base anything you want. Okay, I'll show you again. Functions, there's different menus. Pick miscellaneous, and then you go over to log base anything you want. And we want log base 2, and then we'll type in 1 over 50. Bada bing, bada boom, there's the answer. Okay. Now, if you don't want to use Desmos, or you want to use that change of base formula we just talked about over here, this change of base formula, let me bring it back over. We could use this formula here, and if we did, then we would write, this would be log base whatever we want, like 10, because it's got a nice little calculator button for that. Log base 10 of 1 over 50 divided by log base 10 of 2, whatever this base is down here. Okay, so we could use the change of base formula if you wanted to, and we'd get the same answer. And to prove it, I'll do it right here. Log base 10 of 1 over 50 divided by log base 10 of 2. Look, it's the exact same answer. So you can use Desmos with log base anything you want, or you can use any calculator with a log button, because that log button, if it doesn't write, if they don't have a base written on it, that log button is base 10. And if you're going to use that, then you would do log of the big number divided by log of the baby number. Log of the big number divided by log of the base. Okay? So there you go. So the answer here was negative approximately, let me zoom in a little bit. Whoop. Negative 5.64385, blah, blah, blah. But if they want me to round it to the nearest thousandth, this is where I stop. And that 8 tells me I need to bump it up. So instead of it being 643, it's going to be 644. So negative 5.644. Okay. So again, because it was base 2, I can't just use a regular button unless I do some stuff to it. You can do log base 2 of that though. No worries. Next question. Kapow. So Noah is borrowing $2,000 and paying interest on the loan. And the relationship amount of money in T in years is this equation. And then it says, how long did it take Noah to pay off his loan? Sorry. How long did it take Noah to pay off his loan if the amount he paid to his father was equal to? Okay. So the amount that they give us here in this question then, this little guy, that little guy right there, Is that the time in years? Is this 2,450 years? No. Or was it months? Maybe it was months. Nope, it was years right there. Years. So we're not talking about 2,450 months, right? We're talking about the amount of money that he had. So the equation that we're dealing with then, that goes in there for A. So 2,450 equals 2,000 e to the 0.1 t. And now we're going to solve that equation. So all I did was take out the a, put in the amount they said, and now we're going to solve this equation. So the first step is going to be to get rid of this 2,000 being multiplied, because this is where the letter is, and that's what we got to get by itself. Remember, e is a number. Do not be deceived. It looks like a letter. It's in disguise as a letter, but it's actually a number. We're going to divide both these by 2,000, and we could reduce the fraction, but let's see if it comes out as a cute little answer. I don't think so. 2,450 divided by 2,000. Oh, that's not bad. 1.225. I can handle that. 1.225. 1.225. Ciao. 1.225 equals e to the power of 0.1 t. Now I've got to get that t, the variable, out of the exponent. And the way we get variables out of exponents is to rewrite them as logarithms. So logarithm base e, and we don't write it as an e, we write it as n. ln for natural log. Logarithm base e of the argument 1.225 equals the exponent. And then we want to get the exponent by itself. So I'm going to divide both sides by 0.1 because I want that t by itself. So this cute little guy is my exact answer. That's some number. And I am going to use a handy dandy calculator to figure out exactly what that equals, or approximately, if it tells me to. No, it says give an exact answer with the natural log written in it. That means don't plug it in the calculator. 1.225 divided by 0.1. Let's see what happens. Ka-pa-chow. Okay, so if they say give an exact answer, you don't plug it in the calculator. You don't plug your final answer in the calculator here. You just write down what you got with the log in it. Next, based on these 5 points, aha, so they give me an exponential and they want me to find the logarithm. So the short answer is we are going to switch the places of each of these points. Okay, so this first point here is at 0, 1. And this is the exponential version. So in the log version, it's just going to switch to 1, 0. So I'm going to take this cute little point I made and put it down here. This point is at 1, 2 for the exponential. So for the log, I'm going to switch it. So it's 2, 1. So I'm going to take a point and put it at 2, 1. 2, 1, 2, 1, 2, 1. Okay. And now I have this next point is at 2, 4. So when I switch it, it's going to be 4, 2. Got it? And then we'll do it again. This is 3, 8, so 8, 3. This is 4, 16, so 16, 1, 2, 3, 4. Coolio? Coolio. So exponentials and logs, they are inverses. And inverses, you switch the x and y. Cha, cha, cha. Next question. Consider the equation. Solve for t. Yappa dappa 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 d. Okay, so we are solving an equation again. This time we're trying to get t by itself, t by itself, t by itself. Okay, so divide both sides by this 11 because we are trying to go backwards and get rid of everything that is farthest away from this t, but on the same side of the equal sign. So when we do that, zoom in, zoom in, zoom in. When we do that, we have left 10 to the 5t equals whatever 20 over 11 is. And you know that's not going to come out cute, so I'm going to leave it as that fraction because that decimal is about to be cray-cray. Look at this thing. 20 over 11. You ready for this? I do not want to write all that out because it keeps going. This is irrational, not rational. It repeats a pattern. Oh, actually, it is rational. Sorry, my bad. It is rational. It's a repeating pattern. I don't feel like estimating it. It is rational. It's so rational. All right, so got to get the letter out of the exponent here. So to do that, I'm going to write it as a logarithm. So log base 10 of whatever's over on the left, which we now call the argument of the logarithm, equals whatever the exponent is. Exponent. Oh, exponent. Okay. And then to get that t by itself, we shall divide. I will divide. Oh, because 5 is being multiplied by t. I gotta get rid of it. So now I'm gonna divide. Sorry. Okay, so t is by itself now. You know, I think I'm officially going crazy. It's very possible. This whole alone thing's stuck at my house with these people. It's driving me nuts. Okay, so this is the exact answer. Just writing it out nice and cute so you can see it all in one spot. And then I got to see how do they want the answer. Oh, they want me to write it out exactly. And anytime you do log base 10, you don't have to write the 10. Don't have to write it. I don't want to. You can't make me. Ka, 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 cha, 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 cha. And then divided by 5. So that's the exact answer. And then to do the approximate, we'll plug it into any calculator you like, since log base 10 is on every scientific calculator. Log base 10 of 20 divided by 11. Just make sure you have that whole thing in parentheses with your log before you hit divide by 5. Then hit equals. And it's this cute little answer. I kind of like Desmos better though. But it said 3 places. So all the way over to here. So 0.051. That 9 is going to make it bump up to 0.52. Hey. 0.052. Okay, dokie. Here we go. Next question. Oh, just kidding. I'm done. I did it. Lois Emos, we did it. Okay, so we made a video of how to do, I did at least one of every kind of question that they might throw at you in those 2 videos. And hopefully it's helpful. I missed you, just so you know. Goodbye.